The reality of resonance and conjugated structures. Some molecules, such as nitrate 5, seem to have very atypical electron arrangements given their constituent atoms. For example, why does only one of the oxygens have a double bond? Isn't that unstable? Why is the charged oxygen charged and the other oxygen uncharged, despite them having the same number of outer shell electrons? At A-level chemistry, this is explained away with one word: resonance. But the truth is a little more complicated than that. What resonance means is that the molecule has multiple different forms or resonances which it can take. One where the double bond is at the top of the molecule, one where it's on the left, and so on. A common misconception here is that the molecule simply flips between these three states. This is untrue. The molecule isn't actually described by any of these resonances, but instead exists as the average of each of the states, giving us the following Lewis structure, with a dotted line depicting the mysterious double bond, and the molecule as a whole being charged as opposed to the charge belonging to one oxygen. Now you may wonder, how can the pair of electrons that form the double bond exist in all three places at once? Well, unfortunately, the answer lies within the realm of quantum mechanics. Even in a bond, electrons can exist as a wave. The easiest way to think of electrons as a wave is to simply think of the wave as a way of mapping the probability of a particle being in a specific position at a given time. While in a bond, the possible locations an electron can be are very small, and the probability of them being there is very high. But this is not the case for the electrons in the double bond of nitrate 5, as the wave for these electrons exists in all three possible locations. This means that each of the oxygens is effectively a third of a pi bond within the nitrogen. If you don't believe me, look up the bond length of a nitrate ion. Each of the NO bonds have the same length, which wouldn't happen if one of them was a double bond and the other two were single bonds. If you're confused due to what I said previously about how the waveform of electrons simply describes where they could be and the chance of them being there, don't worry. That explanation is an oversimplification of the wave versions of particles. How exactly that works shouldn't be your greatest concern. Suffice to say, for now, the electrons exist in all three locations at once, but only at the third of their full electromagnetic power. Thank you very much for watching, and goodbye.